Today we'll discuss another question. Analyze the frame shown in figure, taking advantage of symmetry of the frame and loading. So this is two-base symmetrical frame. Here you see this is A, B, C, D, E, F, G, H, I. The top span C, D, I. The load you are having 30 kilonewton meter. And in this portion, the load you are having 20 kilonewton by meter. And the height of the vertical member AB 3 meter and BC is your 3 meter. And the horizontal member B and EH 6 meter each. And the moment of inertia are given CD 2I, DI also 2I, and B 2I, and EH 2I, and the all vertical members, the moment of inertia are given I. So now this is your symmetrical as you concern the loading or from the geometric point of view. So this frame is your symmetrical. And this is your even number of ways here. Here there is your 2 ways, means even number. So when there is your the number of ways is your even number, then you have to take the symmetry along the column line. 2 ways means you have to take along the column vertical member. If 4 ways, you have to take after 2 ways you have to take in column the symmetrical through the column. So here there is your 2 ways. So you have to take the geometry through this column DEF. Since the line of symmetry passes through the column DEF, joint D and E will not rotate. So this joint and this joint will not rotate. As the symmetry passes through this line, so this is not rotate and this joint is also not rotate. Only half of the frame considered for the analysis. You have to consider half of this frame for the analysis of the total frame. You have to analyze this half portion, and other half you have to take the moment what you got this side, that other side you have to take in opposite side, that the moment. So we will consider this portion A, B, C, D, E, F. But here D is your fixed and E is your fixed. Here you have to consider this portion. Here you see this is the substitute frame by considering this half portion, and by taking D and E joint is your fixed, and this is the half portion. So you have to analyze this half portion A, B, C, D, B, E. So here this moment of inertia is given 2I, this is 2I, and this is I and I. This is your 6 meter, and this is 3 meter and 3 meter. So what is your first step? That you have to find out the fixed end moments. By considering all ends are fixed, all end of the members are fixed, and you have to find out the fixed end moments. So here you see, so this is your CD, horizontal span. So the member, the length is your 6 meter. So find out what is the fixed end moment MFCD and MFDC. You know this is your 30 kilonewton by meter UDL. So what is the moment here? Minus WL square by 12. So minus 30 into 6 square by 12. Minus 90 kilonewton meter. So here the fixed end moment is minus 90. And what is the fixed end moment here this side? MFDC. So plus 30 into 6 square by 12. So this is your plus 90 kilonewton meter. Plus 90 kilonewton meter. Then take the span B and find out what is the MFB moment here and what is the moment this side. So here the load you are having 20 kilonewton by meter and the length is your 6 meter. So MFB is your minus 20 into 6 square by 12. This is minus 60 kilonewton meter. And the MFB is your plus 20 into 6 square by 12. So this is your plus 60 kilonewton meter. Then this is the vertical member AB and BC. So in vertical member AB, so what is the moment here? Because here there is no loading. What is the moment? Fixed end moment 0, MFAB 0, and MFB is also 0. Similarly in vertical member BC, MFBC 0 and MFCB is also 0. These are the fixed end moments. Then what is the next step? You have to find out the rotation factors. In this tabular form, you can find out the rotation factor. The first column represent a joint, second column is your member, third column relative stiffness of the member, fourth column is your relative stiffness of the joint, and fifth column is rotation factor. You know, for rotation factor, what is the formula? Minus half into the relative stiffness of the member divided by relative stiffness of the joint. First we'll take here there is two joint, B and C joint. So at B joint, how many members meet? BA, BE and BC. And at a C joint, how many members meet? CB and CD. So here you write first in first column, write B and C, two joint, then member. Member is your BA, here BA, BC and BE. So here you write BA, BC and BE. Similarly at joint C, so here you write CB and CD, CB and CD. Then you first find out what is the relative stiffness of the member, KB. So KB is equal to I by 3. Moment of inertia of this member divided by length of the span. Similarly, the relative stiffness of this member KBC is equal to similarly I by 3. And KB, relative stiffness of the member KB is equal to 2I by 6 is equal to I by 3. So here in this tabular form, this is your represent I by 3, and this is 2I by 6 is equal to I by 3. Similarly, take joint C, and here CB and CD, two members meet. So what is the relative stiffness of this CB? I by 3. And what is the relative stiffness of this CD? 2I by 6. This is your I by 3. 2I by 6 is equal to I by 3. CD 2I by 6 is equal to I by 3, and this is your I by 3. Then find out what is the relative stiffness of the joint. So you see, so this is your I by 3 relative stiffness of the member BA, and BC is your I by 3, and B is your I by 3. So take the relative stiffness of the joint B, I by 3 plus I by 3 plus I by 3. So this is 3I by 3 is equal to I. So this is the relative stiffness of joint B. Similarly, find out the relative stiffness of the joint C. So here also I by 3 plus I by 3. This is equal to 2I by 3. So this is your relative stiffness of the joint C. Then you find out what is the rotation factor. So rotation factor is equal to minus half into relative stiffness of the member divided by relative stiffness of the joint. So here you find out minus half into relative stiffness of the member is your I by 3, and the relative stiffness of the joint is your I. So minus half into K by summation of K, I by 3 divided by I. So this value is equal to minus 1 by 6. Similarly, find out the relative rotation factor of the member BC, minus half into I by 3 divided by I is equal to minus 1 by 6. Similarly, for B, minus half into I by 3 into I is equal to minus 1 by 6. Then for this joint, so this is the relative stiffness of the joint, and this is the relative stiffness of the member. So for CB, UCB, rotation factor of the member CB is equal to minus half into I by 3 divided by 2I by 3. So this value is equal to minus 1 by 4. Similarly for CD also, so this is your minus 1 by 4. These are the rotation factor. Then what is the next step? So then you have to find out what is the rotation moments. You have to find out the rotation moments by considering the rotation factor. So accordingly, you have to find out what is the rotation moments. You know what is the formula already we have discussed in previous classes. So what is the rotation? You have to find out the near end rotation moments. This is the table, because here you are considering the half portion. So this is your joint B and this is joint C. So here you make two blocks at joint B and joint C, and this is DE and A. So this is the block, rectangular block you have to make here at the joint B and C. So in inner block, you know what is the fixed end moment already you have calculated. So here this side is your minus 60 and this side is your plus 60. MFB and MFPB. Similarly, MFCD and MFDC we have calculated minus 90 and this is your plus 90. And here the vertical member, the fixed end moment is your 0, and this side is also 0. and here also 0, and here also 0. So at the end, the piston moment is your 0 in vertical member. Only here in horizontal member there is your piston moment. So what is the piston moment of the joint B? Because this side the piston moment is 0, this side the piston moment is 0, and here you know the piston moment minus 60 plus 0 plus 0. The piston moment of joint B is your minus 60. Similarly, what is the piston moment of joint C? This side is your minus 90, and this side is your the piston moment 0. Minus 90 plus 0 is your equal to minus 90. So that you have to put in inner rectangular box. So minus 60 you have to put in inner rectangular box at the joint B, and this is inner rectangular minus 90 you have to put at the C. Then already you got here what is the rotation factor for BA minus 1 by 6, BC minus 1 by 6, and B minus 1 by 6. So you put here. So this is your BA, this is your BA. So here you put minus 1 by 6, this, and here this is your B. You got the rotation factor minus 1 by 6. And in BC, here you got the rotation factor minus 1 by 6. Similarly, for CB also you got the rotation factor minus 1 by 4. And for CD you got the rotation factor minus 1 by 4. So here you put CB, here you put minus 1 by 4. And for CD, here you put minus 1 by 4 rotation factor. You have to find out what is the near end rotation moment. So you know, so when you find out, first you have to find out M dash BA, then you have to find out M dash B, then you have to find out M dash BC. After this joint, you have to go to joint C, then you have to find out M dash CB, then you have to find out M dash CD. So then that the first cycle will be over. So first we will go for the first cycle and we'll find out what is the near end rotation moment here, here, and here. So what you have to do, because here you see the joint is your fixed. So what is the far end rotation moment here? 0. And here this is also joint. What is the far end rotation moment here? 0. And this side, because at joint B there is your 3 member meets AB, EB, and CB. A, E, and C. These 3 are the far end of joint B. So here this is 0, and this is 0, and this is you have to assume 0. Far end of joint B, C, that you have to assume 0, and you have to find out what is the near end rotation moment here and here and here. So this to 0, and this is you have to assume at joint C, the far end rotation is your 0. So what is the formula? So you have to find out M dash BA. So M dash BA is your equal to UBA into MFB, fixed end moment at joint B, plus the summation of the far end rotation moment, sum of the far end rotation moment, plus sum of that M dash AB. This is the formula. So you have to find out first M dash BA. So M dash BA is your equal to UBA. UBA is your this one, rotation factor of the member BA. This is minus 1 by 6 into minus 60 plus what is the far end rotation moment? Sum of the far end rotation moment 0, and this is also 0, and this side you have to assume 0. Minus 60 plus 0 plus 0 plus 0. After calculation, you will get the value is 6.25. This is the value. Near end rotation moment M dash B. Similarly, find out M dash B. So when we will find out M dash B, so what is the formula? M dash B is equal to UB into MFB plus summation of M dash AB, summation of far end rotation moment. So similarly, here you also find out that M dash B is equal to minus 1 by 6 into minus 60 plus 0 and plus 0. So you get plus 6.25. This side also you have to find out M dash BC is equal to UBC into MFB plus the summation of M dash AB, sum of the far end rotation moment. So this is your so M dash BC is equal to minus 1 by 6 into minus 60, bracket start minus 60 plus 0 plus 0 and plus 0. So here also this value is also 6.25. So here at joint B, so you got the near end rotation moment Md as 6.25 and Md B 6.25 and Md BC is your 6.25. Then you go to the next joint C. So in this joint, you have to find out the near end rotation, this one and this one. So you have to take Md you have to find out, and you have to find out Md. So Md is your equal to what? UCB bracket start the fixed end moment of joint C plus the sum of the far end rotation moment. Sum of the far end rotation, that is the sum of the Md BC. BC. Far end means BC, or you can also say DC. So here you find out Md CB is equal to -1/4 into -90. And this side is your the fixed end moment, rotation moment is your 0, fixed end. But this side, what you have to take? This side already you got here the near end rotation moment when you are considering the joint B. So you got this is the 6.25. So when we are considering the joint C, this moment you have to take as a far end rotation moment for joint C. For joint C, you have to take 6.25 as a far end rotation moment. The formula Md CB is equal to -1/4 into -90 plus 0 plus 6.25. What is the value you will get? So this is your 22.5 you have to put here. So here you got Md CB. Similarly, find out Md CD. So Md CD is equal to UCD into MFC plus summation of Md BC. Here also, this is your Md CD is equal to -1/4 into -90 plus 0, and here this side is your plus 6.25. So after calculation, you will get this is the 22.5. So now first cycle is your over. Then you go for the second cycle, and again you go to the joint B. In the similar way, you find out what is the rotation moment in that cycle. This is 6.51, and here 6.51, and here 6.51. But when you will find out the near end rotation moment in second cycle, so you have to take the far end rotation moment. This side already you got by considering this C joint, you got here the near end. But when you are coming to this joint B, so and you have to find out that the far end rotation moment. So you have to take this value. This side is your 22.5, and this is your fixed 0, and this is your 0. In second cycle, you have to take this 22.5. So you will get 6.51, 6.51, and 6.51 in joint B. Then you have to go to the joint C. So when we find out the Md CB and Md CD, so you have to take this side the far end rotation moment is your 6.51, and this side is your 0. So accordingly, you have to find out what is the near end rotation moment Md CB in second cycle 20.94, and here Md CD 20.94 in second cycle. So now second cycle is your over. Then again you start third cycle, and you go to the joint B. So then here in third cycle, so this side the rotation moment far end 0, this side 0, but this side you have to take 20.94. This side you have to take the result you got in the second cycle at joint C, the near end rotation moment, that you have to take the far end rotation moment of joint B. So 0, 0, and this side 20.94. So by considering these three, so you will find out, because here the Md B is your -1/6 into -60 plus 0 plus 0, and this side is your 20.94. So you will get 6.52. Similarly, here also you will get 6.52, and this side also you will get 6.52. So after completion of this joint B, then you go to the joint C. When you find out the Md CB and Md CD, so the far end rotation moment at joint C, this side you have to take 6.52, and this side is your 0. So when we find out Md CB, so -1/4 into minus 90 plus 6.52 and plus 0. So you will get what is the moment here in third cycle, 20.87, and here also will get 20.87. So now third cycle is your over. Then again you have to go for one more cycle and go to the joint B. Here in joint in fourth cycle, so you have to find out M-BA, M-B, and M-BC. But here you have to take the far end rotational moment of joint B, this column 20.87, and this side 0, 0. So when we find out M-BA, so this is minus 1 by 6 into bracket start minus 60 plus 0, and this side is your 20.87. So you will get the value is your 6.52. Similarly, find out for M-B, this is also 6.52, and find out for M-BC, this is also 6.52. Then you go to the joint C. Then in fourth cycle, so you have to consider this is the far end rotation moment. So by taking this one and this 0, you will find out what is the near end rotation moment M-CB and M-CD. So this is the value 20.87 and 20.87. So the fourth cycle here you see there is the difference between this third and fourth cycle is your 0. Here also 0. Here also 0. Now you stop here. And you take the final value is the rotation moment of the member. So for M-BA you take 6.52, and for M-B you take 6.52, and for M-BC you take 6.52, and M-CB you take 20.87, and M-CD you take 20.87. And here the rotation moment is 0, and here also 0, and here also 0. So these are the rotation moments. Then you find out the final moment. So you know what is the formula for final moment? What is the formula? So because you have to find out here, so what is the final moment MAB, MBA, MBC, MEB, then MBC, MCB, MCD, that you have to find out the final moment. So when we consider this AB member, so final moment MAB is equal to, what is the formula? MAB is equal to MFAB plus 2 M-AB plus M-BA. When we will find out for any member, so MAB is equal to MFAB plus 2 M-AB plus M-BA. So here you see, when we will find out MAB, so here you see the piston moment, this side is your 0, this side is your piston moment is your 0, and the rotation moment is also 0 this side, and this side the rotation moment is your 6.52. So this side piston moment plus this side rotation moment twice into rotation moment is 0, 2 into 0, and this side the rotation moment is your M-BA is your 6.52. So here MAB is equal to, this is your MFAB plus twice M-AB plus M-BA. So this is your equal to 6.52 kilonewton meter. Then find out MBA, the final moment BA. MBA is your equal to MFBA plus 2 M-BA plus M-AB. Twice of the near end rotation moment and once of the far end rotation moment. So for MBA, so the moment is equal to MFBA plus 2 M-BA plus M-AB. So because here you see this side also the piston moment 0, and this side the near end rotation moment is 6.52, and this side the rotation moment is 0. So 2 into 6.52, 0, and piston moment is also 0. So here 0 plus 2 into 6.52 plus 0. So this is your 13.04 kilonewton meter MBA. Similarly, find out MBC, this one. So when we'll find out MBC, so what is the formula? MBC is equal to MFBC plus twice into M-BC plus M-CB. So here you see, here also the piston moment is 0, and here the near end rotational moment is your 6.52, and the Mdc is your 20.87. When you will find out MBC, so you have to take this is near end and this is your far end. So Mdc is your 6.52, Mdc is your 20.87. So here 0 plus 2 into 6.52 plus 20.87. So this is your equal to 33.91 kilonewton meter MBC. Then MB, then you find out MB, this one. So MB is your equal to MFB plus twice into M-B plus M-EB. So here you see MFB is your already you know minus 60, and M-B is your 6.52, and M-EB is your 0. So MB is your equal to minus 60 plus 2 into 6.52 plus 0. Minus 60 plus 2 into 6.52 plus 0. So this is your minus 46.96 kilonewton meter. So here you got MB got. Then find out MCB, then find out MCD. So MCB, here also you need B. Yes, CB, CD. So MCB and MCD. So MCB is your equal to MFCB plus twice into M-CB plus M-BC. So MFCB is your 0 because there is no friction moment, and M-CB is your 20.87. So twice into this value plus M-BC 6.52. So here MCB is your equal to 0 plus 2 into 20.87 plus 6.52. So this is your equal to plus 48.26 kilonewton meter. Then MCD. So MCD is your equal to, here you see MFCD plus twice into M-CD plus M-DC. So you know MFCD is your minus 90, and M-CD is your 20.87, and M-DC is your 0. So MCD is your equal to minus 90 plus 2 into 20.87 plus 0. Minus 90 plus 2 into 20.87 plus 0. So this is a minus 48.626 kilonewton meter. Then MDC and MEB. So in MDC, so here you know MDC is equal to MFDC plus twice into M-DC plus M-CD. So here you know MFDC is your 90, and M-DC is your 0, and M-CD is your 20.87. So MDC is equal to 90 plus 0 plus 20.87. 90 plus 0 plus 20.87. So this is your 110.87 kilonewton meter. Similarly, find out EB. So MEB is equal to MFEB plus twice into M-EB plus M-B. So MFEB is your 60, and MEB is equal to 60 plus 2 into 0 plus 6.52. 0 plus 6.5. So this is your 66.52 kilonewton meter. So these are the final moment at the end of the members. Write this final moment in a tabular form in the frame, because here you MAB you got 6.52, just you write here 6.52, and the MBA you got 13.04, so write 13.04. Then MBC 33.91, then MB minus 46.96, so here you write minus 46.96. Then MCB is your plus 48.26, here you write plus 48.26. Then MCD is your minus 48.26, minus 48.26. Then MDC is your 110.87, here you write 110.87. Then MAB is your 66.52, so here you write 66.52. The other half you have to write the same magnitude but opposite direction, because here this side MDC is your 110.87 and MDI is your minus 110.87, because this is positive value and this side is your negative. And here you see MCD is your minus 48.26 and this side MID is your plus 48.26. And here you see this is your MCB 48.26, and here MIH is your minus 48.26. And here you see this is your 33.91 MBC, and here MHI is your minus 33.91. And here you see MB minus 46.96, and here MHE plus 46.96, and MEB 66.52, and here MEH minus 66.52, and here this is your 6.52, and this is your minus 6.52. So these are the final moments of the whole frame, whole symmetrical frame. After putting the moments, then you have to give the direction of the moment. For positive moment, the direction is your clockwise, and for negative moment, the direction is your anti-clockwise. So here, this is positive. So what is the clockwise direction? You know, along the clock direction, this is clockwise, and opposite to the clock direction, that is your anti-clockwise. 6.52. So here, so this is the direction. This is the direction clockwise. Then 13.04 for this one. So here also this is positive. So clockwise. So this is clockwise. At this joint, this is your clockwise. Then this is your 33.91. So this is also positive. So this is clockwise. For BC, so here for BC, this is also clockwise. Then for B, this is negative. Negative means this is your anti-clockwise. This is anti-clockwise. The direction is anti-clockwise. So this is the anti-clockwise direction. This is anti-clockwise direction. This is clockwise, clockwise, and this is anti-clockwise. So always you have to check at the joint B, the sum of the moment is your coming 0 or not. You have to check at each joint, that should be 0. Similarly, you go to this one, 48.626 MCB, positive, clockwise. Then MCD minus 48.26, negative, anti-clockwise, anti-clockwise. And here 110.87, positive, clockwise, clockwise. And here also 66.52, clockwise, positive, clockwise. Then this side also accordingly you have to give this is your minus 110.87, anti-clockwise, anti-clockwise. So always at joint that should be balanced. This side clockwise, or this side anti-clockwise, clockwise, anti-clockwise. Here this two clockwise is very equal to this anti-clockwise. Here also this is your positive, so this is the direction of clockwise. And here negative, this is the direction anti-clockwise. Here also this is positive, so clockwise, and this is negative, so anti-clockwise. These two are anti-clockwise, anti-clockwise, anti-clockwise. And here minus 6.52, this is anti-clockwise. So these are the direction of moments. After putting the direction of the moment, then easily you can plot the bending moment diagram. Because if you are taking the direction of your inner side, so you have to take this is the moment, inner side. Because here this moment is your 6.52, so this is 6.52 moment inner side. So here take inner side 6.52. Then here you see this arrow mark is your outside. So what is the moment? This one 13.04. Here you take 13.04 outside. Then you join this line. Similarly, what is the moment here and here? This side. Here this moment is your 46.96. This side is your 66.52. This is 46.96 and this is your 66.52. Then you join this line. Then for this member, this is your inner side. So here you take this inner side and this is your outside. So here you take this side and you join this one according to the moment, magnitude of the moment. Similarly, what is the here? This side is your what is the moment? 48.26. This is 1810.87, 48.26. 48.26, 110.87, 48.26. So you take 48.26, 110.87, 48.26 and join this. Similarly, this side also, this is this side and this is this side. This side and this, join this one. Here also in vertical member HI, this is outside, this is inside. These are the negative bending moment diagram, but inside you take positive and the other is your negative. Then what is the load you are given on the beam? So here you see the load is you are given on the beam. So due to this loading, you have to draw the free bending moment diagram. You have to draw the free bending moment diagram for this one and for this one. Here also you have to draw free BMD for this one and this one. Here the 30 kilonewton by meter load is present. So what is the free BMD here? W L square by 8. The maximum ordinate is W L square by 8. You have to find out this one, and after getting this one, then you have to find out what is the maximum positive moment here. Because you know free BMD, you have to find out this one, because already we have discussed in previous classes how to find out this one, this ordinate. Here also, this is the W L square by 8, this total ordinate. What is the value you will get here? Then you have to deduct this portion, then you will get what is the maximum positive moment here. Similarly, here also, the load is given 20 and minus that is you have to find out the free BMD positive bending moment W L square by 8. So W 20 into 6 square by 8. So you will get this value here. Similarly, also you know here and here, this portion you have to find out what is the maximum positive moment here. So this portion you have to deduct. So you have to write here what is the value. Similarly, you will find out what is the maximum positive moment here. This is positive diagram and this diagram is your negative diagram. So this portion is your cancel each other. So only this is negative and this is negative. And here also, and this is positive. Here also this is negative, positive, negative, and this portion is cancelled. And this is your negative, and here this is your positive, this is positive, and here this is negative, positive, negative, positive, negative, negative. This is your negative, positive, negative, positive. So this is the final bending moment diagram. Now all are clear?